What you're doing is you're trying to solve a linear system. Okay, so a linear system has two or more equations, linear equations. So this is the first one, and this is the second one. So this is a system. Okay, to solve means that you're trying to figure out. Well, to solve, you're basically trying to find out what's the value of x and what's the value of y. Okay, that's to solve it. We're trying to find the unknown variables, but we're trying to find out what x value and y value is the same for both of these equations. So whatever x is in the first equation, it's got to be the same number in the second equation, and same with y. Okay, so our solution is whatever we figure out is x and y, and it's got to be true for both of these equations, okay? Well, the first method I'm going to show you is elimination. So what that means is you're trying to eliminate one of the variables, okay? So let's do just an example over here. If I had two x's, for example, and I want to get rid of these two x's, how do I eliminate them? Well, to get rid of them, I would just subtract two x's, right? And I'd have none left. This would be gone.
Oh, subtract 2x, so you do 2x.
Right, like if we had 3 apples and I want to get rid of my 3 apples, I take away the 3 apples. I have none left. So you want to look at the two equations first and see if either of the variables have the same coefficient. That's the number in front of it.
Yeah.
Do any of these have the same coefficient? Because they don't have the same number, the same coefficient, we want to make either the coefficient of the y's the same or the x is the same. Okay, so it doesn't matter. Which one do you want to make the same?
I guess the x's.
Okay, so what multiple do these have in common? What can I multiply this by and multiply this by that will give me the same answer?
2.
So 3 times 2 is 6. That will give me 6x.
Yeah, and
2 times 3 will also give me 6x, right? Yeah. That will make them the same, but I have this negative here, so I have to include the negative sign.
There.
Okay, but if you multiply the first part, the first term by 2, I have to do that to every single term. Okay, so the first equation, I'm going to multiply everything by 2, and the second equation, I'm going to multiply everything by 3, because whatever you do to one term, it's negative, you have to do to every single term. So let's work ahead here. So what's 2y times 2? Positive 4y, good. And then 13 times 2.
Oh, we're doing 13?
Yeah,
we'll
go across, yeah. The first equation is 26. Okay, now we'll do the second equation. We already did this.
Oh, 3 times 2 is 26.
And then 4y times 3 is positive 12y, and then 2 times 3 is 6.
Yeah.
Okay, so what we're trying to do now is we're trying to eliminate, now that this variable, this term, has the same coefficient, I can get rid of the 6's, right?
Yeah.
Now, the problem is here, though, is that this 6 is positive and this one's negative. Okay?
They were not both negative?
No, this one's positive and this one's negative. So we have to figure out how can I get rid of these two. If the signs were the same, so in this example I gave you before, these were both positives, we subtract to get rid of it, right?
Yeah.
If one's a positive, so let's say we have 2 apples and then a negative 2. If I take 2 apples and I add a negative, I cancel them out. They're gone. I have 0 left. So if the two signs are different, and we'll put this in your notes, we're going to add these two equations together. Because if I take 6x and I add a negative, I'm left with 0. Okay? So we're going to add everything. So you want to go in order. So we're going to do 26 plus 6, okay, is 32. I'm going to line up my equal sign. Then I'm going to do the next thing. We have positive 4y plus 12y is 16y. And I've eliminated this. 6x plus negative 6x is 0. So all I'm really left with now is this 16y equals 32. Can you solve for y?
Yes.
Because we want to isolate y. So if I divide this by 16, whatever I do to one side, that will cancel that out.
Yeah.
I have to do to the other side. So this cancels out. Y equals 2.
Oh, okay.
So I've solve my y.
Oh, so it's 32 divided by 16
Right.
is 2.
What I'm trying to do is I'm trying to find x and y.
Yeah.
We just found y.
How do we find x?
Okay, now that you know y, we can take this answer, we can plug it in to either of the equations because we said that this is true for both of them, right?
Yeah.
And if you know one of the variables, you can solve for the other one just by just by isolating the variable. Okay, so I'll show you. So let's choose the first equation. Okay, so we had 3x plus 2y equals 13. This was the original equation we were given. Okay, and we were trying to find x and y. We don't know x, but we know y is 2, right?
And these are going to make coordinates.
Right, exactly, yeah.
Oh.
So we're going to place this y with our answer. Okay, we said that y is equal to 2. Well, now that we know one of the variables, we can solve for the other one. You can always solve an equation when you only have one unknown. We couldn't solve it before just by isolation because we didn't know either of them. So let's just simplify this. 3x plus 4 equals 13. We want to get rid of this plus 4. Bring it to the other side. What does it become?
I'm never doing it. Class
The
side,
plus 14 becomes, plus 4 becomes minus.
Minus 4?
Good.
Okay. Because when you go on the other side, become the
Yeah.
negative, right?
So 13 take away 4 is 9. And I need to isolate, solve for x.
So 3x under?
Yeah, divided by 3.
Oh.
And then divide by 3. This cancels out.
Okay. I thought you had to put x under the 3.
No, you just want to divide it by itself.
3x.
Yeah, and then 9 divided by 3. X equals 3.
Oh, so that makes 3.
Right.
Oh, what is that?
We just found the solution to this linear system. We just found that x is 3 and y is 2. And we said that this is true for both of the equations. Well, let's check, okay? We're going to check to see if this is true. So let's go back to our first equation, which was, we're going to check by using the two original equations.
Yeah.
According to our solution, this 3 is true for the x value for both of them, and we found that y is 2 for both equations. It should make the equations balance. So we can check this. We can just solve it. 3 times 3 plus 2 times 2 equals 13, and negative 2 times 3 plus 4 times 2. We want to see if this x and y value and this x and y value is true for both of them, okay? So 3 times 3, so we can just check this. 9 plus 2 times 2 is 4. What's 9 plus 4?
9 plus 4, 9, 10, 12, 13.
Well, it works for this one. The left side equals the right side. So this is true for the first equation.
Yeah.
And then we have negative 6 plus 8. Yeah. Negative 6 plus 8 is 2. Left side equals right side. It's true for the second equation. So this is a solution.
6 plus 8, 2.
Made with Doodlecast Pro.